Hey, thank you all for joining us today on this talk on how to avoid observability meltdown using metrics, logs, and tracing. I'm Sid, I'm an architect at Habu, and I lead the dev side of initiatives at Habu. And with me today,
Hi, my name is Peter Hahn. I'm a senior engineer at Ketch, working with Anton and others.
Hi guys, I'm Tyler. I'm a platform engineer at Ketch. I'm others as Peter's referenced. So.
Cool. So let's just talk about observability. Right? So what is all this hype about? Right? So after Kubernetes and DevOps, observability is the new trending thing right now. So what exactly is observability? Right? Observability lets you understand a system from outside by just asking you questions without knowing the internals of a system. Right? It will help you deal with unknowns. Especially in software, observability is the ability to ask new questions about the health of your running services without deploying new code or code installation. How does it differ from monitoring? Right? So I just so I kind of write this code, so I steal it. So observability is your bank telling you that you are overdrawn. Oh, sorry, so monitoring is your bank telling you that you are overdrawn, but observability is the ability to tell that you are running out of money because you are spending too much money on chocolates, cakes, and sweets because you have recorded data on what you have spent your money on, right? So this is the biggest difference between monitoring and observability, right? That we are all used to kind of monitoring where we used to instrument our code and then we used to get alerted on call on something's not working. But that didn't give you a good context on why things are not working the way they should be working. That is where observability comes into play. Right? That observability is like you are emitting some you are kind of emitting some telemetry data, and you are hoping that you can deal with known unknowns and known unknowns data when when there are issues in production. What are some of the challenges of observability in today's era? Right? So as you see, companies are kind of moving towards cloud. They are trying to embrace maybe a single cloud vendor, maybe a poly-cloud, multi-cloud environment. So observability becomes more challenging over there because now you have a different cloud vendors with their own set of creating containers, nodes, VPCs, whatnot. Right? And also, if you are embracing on the Kubernetes journey, right now, if you think about pet versus cattle's analogy, okay, back in time, if you were to spin some software on on-prem instances, so what you used to do, you used to kind of provision a dedicated nodes, give it a name, and then kind of do it. Right? And the only way you could add new nodes is that if you had to go to your and schema and provision things, right? If let's say something went wrong with your node, so you had to take care of that node explicitly. That is, that was all the pet and all. But in today's age, where everything is ephemeral, you can spin up containers, nodes using spot instances up and down. It is kind of cat where you are not associating names with your nodes or servers. Because your software is kind of resilient, it could deal with network failures. Right? So now observability gets more challenging because now you have dynamic containers, nodes coming up. Also, because of this architecture, the volume, velocity, and variety of data has increased. So now you not just have to monitor a single node, you have to monitor multiple nodes, multiple containers, multiple pods across the environment. And also, if you are not embracing the DevOps culture properly, and if you have siloed DevOps team, observability becomes a problem because your application team is just interested in writing application code, and they will just throw over the code to the ops. Right? So now, if you get alerted in production about your outage something, now the ops team, I would say without having context or observability into your app, into your software, will know the thing, will know what exactly went wrong with the application. Right? So this is a classic analogy between I would say monolithic versus microservices. So if it was a monolithic architecture, it is kind of really simple because the path between the client and server is generally through a finite collection of points. Monitoring, observing monolithic architecture was quite simple because you just had to take care of your single database server, your few nodes, and your single application. But if you think of microservices, in a distributed system, the network becomes a lot more critical and complex. So because now the path between the client and server got a lot more winding and then kind of harder to reason about. This network complexity is the causal origin of an observability challenge. Now when you start talking about observability, essentially observability is nothing but it is the intersection of three data points, right? Those are called the key pillars of observability: logs, metrics, and distributed traces. So only if you have these three things properly instrumented in your code, right? If you're setting the right logs with context, if you have metrics with the same context with them, and if you have distributed traces across your different microservices, that is when you are truly on the journey of observability. So let's just go to a quick 101 on what are logs, metrics, and traces, and then I will do a demo on observability. So if you think about traditional logs, everyone knows what logs are. Like logs are a timestamp event which is emitted by your service. And if things go wrong in production, you will just hope that you are looking into your logs across multiple services, and you are hoping that you can find some stack trace at that point of time. And using that stack trace or some context, you can try to stitch back things. This is the application that has gone wrong. Right? This is a classic way of just having logs to observe the system. What are some of the best practices to have logging? Right? So first and foremost, you should invest into centralized logging. That is to find the root cause of any error. If you have to search through or sift through log files across different application servers, you are just hoping that you are on the right server at that right point of time. Right? So which is completely not possible. So first thing you should try to invest into a tool which will centralize all your logs across containers and move into one single place. Right? Now you can query that tool to get some insight about your logs across services. But if you want to simplify your query in that centralized tool, you need to have some structure around your logs. Because if you are let's say writing logs without any structure, you are just hoping that you would write some string pattern matching across your log. And let's say that you are emitting some Apache HTTP logs. Then you have to ensure that you know how to grab or block the Apache HTTP logs using string pattern matching. But if you convert those logs into standard JSON structure, wherein you have timestamp, you have levels, you have some context. So now the querying JSON in that centralized tool would be easier. The third is logs without context do not make sense. So if you are emitting logs, it is always recommended that you emit some context which are at the infrastructure level, plus your application level. Like every log should have some baggage which says this is the host, this is the environment, this is the pod, this is the container, plus this is my application user ID, this is my organization ID, this is my client ID. That way, let's say if things go kind of wrong in production, and if an organization customer comes to you and says something went wrong, now you know who that user is, you know who that organization is. You can directly go to your tool and say, get me all logs in this time frame for this organization. Right? So it will just filter out your logs and just give you a view of that organization. Right? So you can add context depending on your application model. There are some common patterns on how to do structured logging with context across all your services, without going and writing the log code into every Java method or function. Right? So if it is Java, you can use some message that is context, which is your interceptors, which is your common shim layer that you can instrument right at your HTTP entry point. You can instrument that in your gRPC entry point. You can instrument in your HTTP outgoing clients, gRPC outgoing client. That way, all HTTP, gRPC are kind of requests coming into your server, and every request that is going out of your server will have that structure in place. So you don't have to instrument your code at every time. Similarly, if it comes to Go, there are patterns wherein you can just write the library one and you can just intercept that. So you can just add that into your logging context, and then you can inject that logging context into your different interceptors. Then comes level, right? I'm pretty sure you are all aware that logs, when it comes to logs, you have got different levels, like the error, on, and for debug. So depending on your use case, you should try to ensure that you are not, you are not, I would say, spreading out logs which do not make sense in your, right? So if you see logs which are at info levels and which do not make sense, ideally they could have been suppressed into debug levels. Okay? Hot versus cold persistence. Logs are expensive because over a period of time you have DBs and DBs of logs every month over. Right? So you have to decide that how much window makes sense for your tool to be queryable. That will become your hot store. And then for compliance reasons, you have to archive your logs, for a year or two for different reasons. So you have to decide on your cold persistence. A quick primer on metrics. Metrics are aggregations over a period of time of some unique data about your infrastructure or your custom application. It could be either some host level metrics or it could be your application level metrics. This is the second pillar of observability. When you think about metrics, it could be either your infrastructure metrics that are at your host level, container level, pod levels, where you don't have to do it multiple times across your services. You just have to inject some agent or whatnot on your host or something. Then comes your application metric. Right? This is what needs to be decided as the owner of the bounded context. Right? Application metrics are, let's say that you have a service which is kind of spreading out, I would say, notification emails to the user. And now, if you want to build a report on how many notifications were sent successfully versus how many failed, that is where you have to use custom application metrics in your code, right? So you have to go and instrument your code and say, at this place, this is the function, this is my user ID, this is my organization ID, and this is where the email was actually sent. Now, depending on what metrics do you want, it could either be a simple counter which can go up and down, right? So you can say number of emails sent per day, or you can have gauges. Right? Gauges are a single atomic value which is observed at a single point of time. Right? So you can say that if you have a message queue, right, and there are messages that are getting produced into that queue, and then there are messages that are getting consumed from the queue. But at any point of time, if you want to know the number of in-flight messages, right, that is a gauge. That will say that any time that you are trying to observe that value, you will see a single number. That is your gauge. Right? And then there are histogram summaries, for things like observing your HTTP latency, gRPC latencies. You can record things and you can put them into different buckets, which are your histograms, and that way you can go into your metrics tool and build charts, visualizations, and get some quantize across different buckets. And you can see that give me the P50, P95, P99 of my HTTP. Right? So that's only possible if you have histograms. Summaries are an old way of doing histogram, wherein the quantiles are decided in your client, and before even sending out the metric, you are doing the P50, P90 in your client side, right? So I would say we should stop doing summaries, we should stick to histograms. Again, when it comes to common interceptors, if you have some common shim layer for your infrastructure and for application level, you should look at gRPC and HTTP interceptor. Just do it once, that way your application team is not bothered. There are some patterns around metrics. There is this red pattern, there is this use pattern. Red means that if you have an HTTP application server, generally you would check the request rate, you would check the error rate, and you would check the latency of the request. Right? So this is a pattern that is followed across the industry. That for HTTP gRPC, you should follow red pattern. And for your infrastructure host level metric, you should follow use pattern. That means what is the use of what is saturation error and the utilization of your host. Right? So there are some good articles around how Google does it at scale. Okay. One more important thing about metrics is the cardinality, right? Because when you send metrics, it is going into a time series database. Every metric can have different dimensions. So the number of dimensions and the unique values for each dimension. Let's say that I'm sending a metrics of HTTP request count. And over there, if I have a dimension called a path is equal to /get, operation is equal to this and this. If the HTTP GET request has got a query path, and if it can be any custom arbitrary value, that means that for every HTTP GET request with a custom query pattern, you are kind of emitting a new metric, right? Eventually that will get stored as a new metric in your time series data. So now when you go and query your time series database for metric, it would just explode, right? So whenever you are doing custom application metrics, you should look at the cardinality of value of the metrics. Always try to keep it within hundreds or at max counts. Okay. Important thing about observability is this is where it gets interesting. Is distributed trace, right? So logs and metrics everyone knows. But distributed tracing is something that I've seen that companies do not invest in. Okay. What is distributed tracing? Distributed tracing involves two things. It is traces and it is spans. Right? Trace records the path taken by the request as it propagates through different microservices. Right? A span is a single unit, is a single unit of work within that trace. Right? So, for example, let's say that you have a user who has initiated one single request, which is going through a service which is your API service, and your API service is making another call internally to another service called consumer service. This could be any service, right? So your customer service can make a call to your database, your customer service can make a call to Amazon SDK. But this is a simple example. Now the end-to-end a request will have a unique ID. So let's just call it the trace ID. So this end-to-end thing becomes your trace. Let's say it is 1, 2, 3, 4. And every operation between different microservices or any operation within a microservice, and if it can be logically divided into a span, that will have its own span with its own span ID. Okay? So what this gives you is that now if I'm trying to observe this system from outside, and if I had get a HTTP request, and if I got back the response, and if that response gave me some kind of unique ID and said, this HTTP request has got this trace ID, which is completely unique to this HTTP. Now, if I have the trace ID, I can go into distributed tracing tools, which I will talk about and as soon as I give the trace ID, I will get the entire flame graph, or I can get the entire view of what happened with that request. Where did it start? Where did it go next? What were all the spans? What happened with each span? So now if you see these requests going to external services, to cloud vendors, and if you have proper instrumentation in your SDKs, suddenly you will have a flame graph view of all the network calls that were made for the networks. Okay. This is important for distributed tracing because without this, if things go wrong in your distributed environment, you will get logs. That's fine. You will get metrics, but you will not be able to identify where exactly is the problem for that single request and what happened with that request. How much time it took. Again, some best practices around distributed tracing. As with logs and metrics, right? You should always send some baggage context with your distributed tracing, right? So when a service goes from a service A to service B to service C, if you pass in some baggage context, right? It could be your organization ID, it could be your user ID. Now, even if you don't have the trace ID, let's say that an organization user came to you and said, our users are finding it difficult to log into your platform. And if you want to identify, is it just this organization or is it a global outage something, right? So if you know the organization ID, you can go to your tool and see what exactly is happening with that organization ID. So you will, if you use the organization ID dimension, you can just build on that. You will get a flame graph view of all the HTTP requests for that organization, and then you can try to identify, there is something wrong with this organization ID because there is a function in service B which is choking because of some external update. Right? So that way you can try to pinpoint on a single organization. How do these traces get propagated across services? There are some specifications about that. There's W3C trace content, there is this B3C trace. These are open specifications, you don't have to learn around that. That means that if you use the right tool, if you use the right SDK, that SDK will ensure that it could be Java, Python, Go, whatnot. It would follow either of these specifications to do your trace content. Implicit versus explicit, either if you use these specifications, it would be an implicit, but if you have some additional attributes like your organization ID, you can add it to the one of these I would say one of these trace context propagation, that becomes your explicit, wherein you are deciding that this additional baggage needs to be added. Okay, so with this said, for sure, this is a complex problem, and that is where different cloud vendors are trying to make money on that. Right? There are tools everywhere. There are open source tools, there are cloud vendor tools. Right? If you stick to cloud vendor tool, great, right? They will give you all the logging, metric, distributed tracing, but you are getting a suck into them, right? Because they will give you agents, they will give you SDKs wherein you have to go and explicitly instrument your host with their agent, or you have to go and explicitly instrument your code with their SDK. So most likely, if you get married to them once you are kind of, I would say you are open to them, right? But then there are open source options as well. There are tools wherein without going to cloud vendor, you can use that tool. But again, that tool would need you to have an agent specific to that. Right? There are tools like Prometheus, Grafana, Jaeger, whatnot. Where, yes, it is possible to do these things, but then again, you will have to instrument your code specific to that tool's use. Okay? This is where it all got complex. Right? That is why observability is a big problem right now. But what if I tell you that there is something called as OpenTelemetry, right? Which is an open source solution, and it can help you build pipelines for your observability, for your end-to-end observability. Right? So what exactly is OpenTelemetry? OpenTelemetry is an open source specification that is a collection of different tools, APIs, SDKs. It is completely vendor agnostic. Right? That it was built explicitly that be it any programming language, Go, Java, Python, without knowing what tool you would be eventually using, right? You can still go ahead and start instrumenting your code, your agent with this specification. That means that you don't have to decide on your storage package, so that you don't have to decide on your open source tool or your cloud vendor before even thinking about observability. So as an application engineer, you can straight away start using OpenTelemetry and say, this is where I need distributed tracing, this is where I need custom application, this is where I need host metrics. And then your DevOps team or your finance team, depending on how deep your pockets are, you can choose the right tool. So how does OpenTelemetry work? Right? This is just a 100,000 foot view of OpenTelemetry. On the left side, you have client SDKs given by OpenTelemetry. So there's a big open source community who is writing APIs, SDKs, exporters for OpenTelemetry. This is all open source. You can go ahead and instrument your code in Java, Python, start using either their APIs, either their SDKs, or if you're into auto instrumentation, wherein you don't want to instrument your code, you can use their agent. So for Java, they have got an open source Java agent. You just have to inject it with your Java. So that is how you instrument your code, and that is what you have to. Then there is an OpenTelemetry collector, which is a service, or it could be a pod, it could be a container, wherein you will have to host that in your infrastructure, which is an open source. That will start receiving logs, metric traces from your exporter, right? So all your applications which were instrumented would start sending telemetry data to this OpenTelemetry collector. It could either receive on the gRPC endpoints, or it could either receive on HTTP. Right? So your code will kind of remit metrics either on the gRPC endpoint or the HTTP endpoint of OpenTelemetry. OpenTelemetry, within its bounded context, has got multiple pipelines, wherein you can do some processing of your logs, traces, you can do some transformation, wherein you can say, okay, drop these metrics, drop these filters, enhance these metrics with some additional attributes. So you can write some complex transformation in, and then right at the tail end is where OLT collector shines. Right? So now you have your logs metrics tracing flowing into your OpenTelemetry collector, and now OpenTelemetry collector gives you the capability that you can decide whether you want to embed this into Prometheus, you want to embed this into Jaeger, Datadog, New Relic, Splunk, Signos, Honeycomb, whatnot. So now you didn't have to decide on your tool first before instrumenting the code. Right? So as an application engineer, you just have to take care of this. your DevOps team took care of your OpenTelemetry collector, and your engineering executives or your finance team took care of the tools. Cool. So let's do a quick demo. We are already 25 minutes into our talk. Let's do a quick demo of. I'll just show you. Again. Can you just put this? Just put this ID. ID over there. Okay, so what I'm going to demo right now is just pull everything on the left first. You see it? Okay, cool. So what I'm going to demo right now is how I've used how I've used OpenTelemetry to instrument a couple of services, a few written in Java and a few written in Go. I will just invoke few HTTP requests, and I will take you through different tools, a couple of open source tools, and a few vendor tools, and just show you how they usually use and how you can start exploring using OpenTelemetry. So there is this API gateway service, which is the entry point, which is built using Spring Boot. It just has REST patterns. Then there is an external API service which is sitting below it. It is also built on Java Spring Boot. It will have REST as well as gRPC. And then you have two more services which is at the ground level. One is the user service built in Go, which only has gRPC, and then you have a clean room service which is specific to our domain. And it is also built in Go. So those are some of the services, and when it comes to tool, I will show you how distributed tracing looks in a tool called Habu, which is open source. I will show you how metrics looks like in Promises. I will just show you how it looks. I will not drill down, maybe Peter can drill down into this more. And then I will just take you into a Datadog news. This is not a talk track from them, so I will not go into the details of Datadog. Okay. So what I have is I have created a
I just have one quick question.
Sure.
You show traces and metrics. Are those tools only capable of the things that are in the parentheses there, or?
Yes. So Jaeger is only for distributed tracing. Prometheus is for metrics. You have Locky, which is for logging. You have Elasticsearch ELK, which is for logs. Right. So when it comes to open source, that is the complexity that you have to stitch things. A Grafana has got Locky. It has got a tempo, wherein you can stitch logs and tracing together. Right? But still, that is where these vendors shine. Right? That they have everything in one place, but they are expensive. So I have the service up and running. So as part of the Docker Compose, the services are running. The OpenTelemetry collector is also running. Now, if I go to my Postman. So now, if I go to my Postman and if I just make a HTTP request, this is a sample authentication API request that I'm making. So I made an HTTP call. I got some access token. I am taking this access token. I'm making one more API call. So I'm making one more API call with this access token, which is which has given me a 200 response. This is trying to get one of our user objects in a system. And then I will try to make one more API call, which is just a normal internal API call. This is not going to our external API gateway. And I will also, and here what I've did is, I've invoked an API with a wrong HTTP method. Right? So this API endpoint only supports post, but I made a get call. So let's say this is what happened with your system, and your user came back to you and said something's not loading. So now since everything is instrumented with open telemetry, wherein the Java agent, so the Java code has the Java agent version of the open telemetry, and the Go code has the Go instrumentation SDK code for an open telemetry. Now if you go into your tools, let's say that you start with Jaeger. Right? So this is an open source tool. There are multiple things you can do with Jaeger. Let's say the first thing that you want to see is what are all the services that are deployed, that were actually instrumented. So over here now you will see a list of all the services that were instrumented with a distributed tracing. You can go into one of the services, you can say, get me all the traces for that service. So now if you look at API gateway, it will give you all the HTTP endpoints that were hit for that service. Right? So these are all the traces. Every trace has an ID. So if you go to Postman, if you look at the response, every response will have an X request ID. So every HTTP request that comes into Habu has this X request ID associated. Be it directionally, API, be it and this is the trace ID. So if you just copy paste this trace ID and if you go to Jaeger, you can say, okay, I'm only interested to know what happened with this request. So see, this is the end-to-end flame graph. So it will show you that this started at API gateway, it went into a service called user service and it failed because of something, right? So it's a method not found, which is your focus. So this is just an example of how using Jaeger you can also have a look at your service dependency. Right? So if you see this is eventually what happened with your HTTP request calls, it was trying to trace it. So now this will give you a view of your dependency. Right? So you have API gateway right at the top, there's an external API server, there are two services right at the bottom. So think of this that if you have let's say 20s to 30s microservices running, you will get a good view of your microservice. This is just Jaeger. It will also give you, possibilities where you can build some red metrics around your HTTP gRPC call. Right? So it has automatically built for API gateway for all these services. It will give you some metrics around your latency, error rate, and your metrics. The next tool is, so this is for distributed tracing.
And does the instrumentation come essentially automatically for plugging in the open telemetry into your code base?
Good. So for Java, you have got agents. For Go, you just have to write a bit of code. I will show you. Actually, I can use it. For Python, also you have a bit of code. So yes, there are SDKs written for that. Let's go quick switch to Prometheus. So as I said, right, that was distributed tracing. If you are interested in Prometheus, you can just go to Prometheus and I'm saying, give me all metrics for this service. I will not go into the details of Prometheus. I will let you do that. And then these are examples of an open source tools, right? But using open telemetry, it was also possible to use something like Datadog, where now everything is a Datadog asset. Right? All my services are in Datadog. My distributed tracing, my logs metrics are Datadog. I can go into one service and say what happened with the service, get me the metrics. I can go into the tracing. It will get me all the traces that happen right now. I can go into the flame graph. Things exactly that I could do in Prometheus Jaeger, and I'm doing it in Datadog. Similarly, I can, if I have chosen to use New Relic, not Datadog, right? So here also I can go into a New Relic. I can look into all my services. So all my services which were instrumented have shown up, and then I can. Similar to Datadog or open source tool, I can go to, and I can look at distributed tracing logs. But that's it from.
Just a quick question. My problem with things like New Relic and Datadog has always been that you can't drill down into, it only gives you aggregations. In this mode, can you drill down into every single trace?
You can drill down to a log. The log will have an X request ID. You can say, take me to the distributed view of this, you can go to the distributed view, and from there you can also go to the augmented view. That is observability. Observability is like only if you can stitch these three things. So with that, I will just pass it on to people who talk about observability at Ketch. Sorry, Ketch, and I will.
So at Ketch, we do a slightly different approach to our observability. We try to do all that. Before we started doing the observability infrastructure, we did a cost-benefit analysis. We took a look at all the vendor cost. And the vendors usually will charge you by, say, per metric, per log line, per trace line, those kind of way. We took a look at the cost of that, and we took a look at the open source side. Open source side, then you have to deal with, obviously, you don't have any license fees or anything along those lines, but there will be dollar values of running the servers. Then there will be time and effort that you need to invest in. At Ketch, we were lucky enough to have a pretty good infrastructure team already there. So our time and effort benefit wasn't too bad. Our time and effort cost wasn't too bad. And our number of our metrics and logs were significant enough that if we were going down the data log or the new relic, the cost would be significantly higher for us. So we have started going down more of the open source side. So on metrics, we do Prometheus, Grafana, Thanos, I'll show it to you later. On the logs, we handle FluentBit, and we're actively looking into a log stack, possibly going to locate. For traces, we've done a good chunk of work towards Jaeger and working towards that front. So for today, I just want to give you a quick look at our Prometheus. Prometheus, it's very simple metric that you guys are looking at here. You're looking at the number of pods that we're running for one of our services. You can tell going from closer to sometime, I think it was earlier today, it went up because of just slightly higher loads when I was working on it. Came back down. For Prometheus, it was written by SoundCloud way back when as the monitoring solution for Kubernetes. It has now become de facto the monitoring solution for Kubernetes infrastructure. The downside of it, however, though, for them, they were looking to get short-term metrics, and by short-term I mean, generally speaking, a couple of weeks. You can stretch that out to maybe a month or two, but after that, Prometheus will start to suffer performance degradation. It just is not built to handle that much metric with that long a time frame. Most people are interested in a lot more than just 2 weeks worth of data. So out comes Thanos. Thanos' job is to go back to back up all the metrics out of Prometheus and up to S3. Then combine the S3 data and real-time Prometheus data into one. So you can have, if you're willing to pay S3 cost, you can have unlimited amount of data going back to the beginning of time. So on the Prometheus side, you will notice how the line ends right here. That is exactly 7 days worth of data, because that's the configuration that we have set. Whereas Themis, same data, goes all the way back. Right? So that's how we keep it up. Then there is also Grafana. Grafana.
Just a quick question. Is the Prometheus built into Thanos essentially? So it's the same interface as Prometheus?
Thanos is an augmentation on top of Prometheus. So you deploy Prometheus and then you deploy Thanos. Thanos is purposely trying to make their UI look just like Prometheus because they want it to be a plug and play replacement. Then, I mean, obviously these graphs and metrics are fantastic, but you want a little more nicer way of looking at things. So outcomes. Grafana, this is a chart that I've been building slowly. The whole thing took me about an hour or so to build. Grafana's sole job is data visualization. How do you display all the metrics that you have collected in a way that makes sense to you? So you can do a lot more graphs, numbers, pie charts. We have some histograms, flame graphs, a bunch of different things, so that you can have a nice view of your system at any given point in time. And yeah, Tyler, you want to come up and talk about the future?
Let's do it. So, as Sid gave you guys a pretty good overview of observability as a whole, and then as Peter kind of went in towards what we do at Ketch with our open source solution, I want to cover some things that we will continue to do to build out our observability platform. And if you are trying to take some of these concepts back, definitely things to keep in mind to incorporate. There's three main things that I want to focus on speaking about in terms of what our future goals are and what you can do to help improve your monitoring, alerting, and observability platform. The first one we're going to go over with actually managing our monitoring, alerting, and observability stack with a tool called Flux. This isn't going to be a deep dive on how Flux works, so I advise you guys to check out Peter's talk later in the day. He'll be doing a big deep dive on that. I'm going to do a brief talk on improving developer accessibility and experience. And there's not going to be too much here, but this is more of like best practices for being sort of on the platform side when you create these tool chains and provide this functionality to your developers that are actually building the applications. Because obviously the last thing you want to do is put all this time into building this really great platform that has all these features and enables developers to have all these things, but then they're completely unaware of it and never leverage it. And what's the point of all that time that you just invested? And then lastly, I'd like to go over a really cool thing that you can do with Prometheus stack and Prometheus in general with its alert manager integration. Use a tool called Robusta, in which you would be able to actually automate the remediation for your alerts that you would get through Alert Manager. So obviously what I want to do, point out with Flux, very briefly, Flux is a CI tool for Kubernetes clusters where Flux is going to reconcile with the source and it'll constantly present that and manage your Kubernetes cluster to a certain state. So if you're familiar with infrastructure code, Flux is essentially a tool for that. In my opinion, if you're managing Kubernetes clusters in any capacity and you're not using Flux, you're doing it wrong. Let Flux and let Helm do the heavy lifting with your Kubernetes clusters. So if you go down the route of doing open source and say you do want to leverage the Prometheus stack, the one aspect of Prometheus stack and it being open source is the rapid development that goes on with it. And what that means is that as cluster operators and administrators that we're constantly forced to have rapid upgrades and we're constantly forced to do CRE maintenance, right? So we actually are in the process of catching up now at Ketch where we had a very outdated Prometheus stack. And these are all problems that come with it, right? So if it's not managed by Flux, you're talking about manually upgrading your CIDs with every major version release. If you guys follow Prometheus stack, it's not uncommon for a new version or a new major version to get released every 2 to 3 days. So you're going to want to manage it with Flux. So Flux can easily manage your CIDs for you, CRDs for you. And then what's really cool about the Flux configuration is that you can actually use logic for your major and minor version upgrades. So you can tell Flux, I want to take every upgrade up until major version X, and it'll automatically do that. And obviously, say you split out your clusters, production, QA, testing, your testing one isn't going to get bound. Your testing will always take the upgrades, and then you have that sort of testing flow for you. pursue this sort of observability and whatnot, the next step to take, the next level would be obviously to automate the actual remediation procedure for these alerts, right? So obviously with an observability platform, we gain a lot of insight and information as to what's going on, and occasionally things are going to break, things are going to go wrong. One of the big points that I had spoke about earlier was that when you start considering the scale of clusters along with microservices and whatnot, you start to get a very large and complex and busy environment that you as a platform operator and admin are responsible for maintaining. And what we want to do in this platform SRE DevOps world is that we want to automate everything. Like I keep going back to the idea of let the technology do the heavy lifting for you. So if you were going to go down this route of building out your own platform, I would highly encourage everyone to investigate a tool called Robusta, which integrates very naturally with Prometheus stack. So Prometheus Alert Manager, it's free. You can deploy it within 1 to 2 minutes inside your cluster. And obviously open source, and if you're familiar with the Cloud Native Computing Foundation, Robusta is a sponsored project by them, so there is actual platform behind it. And that is, for the most part, what I wanted to bring up in terms of things to focus on if you're trying to move forward with this and maybe take back to your own stacks.
Thank you, Peter. Thank you, Tyler. Yeah, so just a closing thought that you cannot buy observability. It is a lot more than log metrics and traces. It has to be something in your engineering culture, right? That you think of observability before writing every line of code. Yeah, and with that, thank you all. Thanks, Peter. Thanks, Tyler. Any questions? Sure, go ahead.
Have you found that support engineer types can use the tracing tools to help pinpoint problems, or who has been the main customer of?
Yes, absolutely. Right. So at Habu, what we do is any error that pops up in an application, right? Let's say Habu application. Let's say I have a customer I have logged in and let's say something went wrong, right? We would show a pop-up with a trace ID and say something went wrong. Oops, please contact Habu support with a trace ID. And then our level 1 support, right? Our customer success specialist, they have access to that tool. They will do the first line of defense. They will just use the trace ID and find a general pattern over there. And then they will create dev tickets for us with that context. Right? So that way, when we start looking to things, we don't have to go through the top level and say what customer, where it happened, when it happened. We do have all the context because of the end-to-end responsibilities.
I used to work at a company that wrote much worse software than Habu, so we had a lot more errors. But it was really nice to see once we had a lot of errors, we go through the log and go line by line. Exactly what happened, which service called what with which parameters. We can chase after that. It makes debugging so much easier.
How much work setting up the open source infrastructure compared to using Slayer?
Yes, so if you use Open Elementary, it should. So what stack are you on? The
We
programming
use
language?
it all day, so we don't use open source. We publish visualizations on the publish out data.
Perfect. Right. So if you are on Java or Scala, let's say that if you say Java -jar and your jar name, with that you just have to say -d open telemetry open source agent.jar. Just provide your service again. So it could be foo bar service. That's it. Now your entire application is instrumented with open telemetry metrics. Now you just have to run an open telemetry collector, which is again open source.
But those connectors like Jaeger and those, there's a much work getting those to support the kind of scale you need.
Jaeger is the exporter tool of your open telemetry collector, right? So you have a Java stack instrumented.
Yeah.
You have the open telemetry collector, which has got no idea what Jaeger is. Right? That is now you can decide whether you want to run a Jaeger, Prometheus, Jaeger. So that part, if let's say you want to stick with let's say Prometheus Jaeger, right? It should not take you more than half an hour to spend. But monitoring, maintaining that itself can be complex.
Yeah.
So that is where you decide whether you build versus buy.
Yeah, that did support that scale.
I would say when it comes to observability, when it comes to monitoring, you don't want your observability tools to go down when your application goes down. Right? So let's say that there is something wrong with my DNS in Kubernetes. Now, if my promise itself is down, if my Jaeger itself is down, I can't even fetch. So that is where I am of the opinion that if you have some money, go and choose some cloud vendor which will give you a different view of the system. Yeah. But yeah, that's just a personal.
Chair will disagree, naturally so. Tyler did already talk where he did it Robusta. Robusta has a nice little challenge on their website. If you can deploy Robusta within 97 something seconds, and they will videotape that, they will send you a coffee mug for Robusta. That's the bar that they have. Again, you have a much bigger scale than what they're, what that simple thing is going to do. There's a little bit more thinking of that, but we're not talking about months and months of somebody's time.
If you have Kubernetes, if you have running pods, and if you're using either Flask, Argo CD on Helm or something, just spinning up these things take 15-20 minutes. Because everything is customized, Helm charts are ready with you. Cool, guys. Thank you so much, all. Have a nice day.